Welcome to the continuation of my video series on statistical analysis. In this video, I will be taking you through a worked example of simple linear regression analysis. And this is the first part of the video series. There's another one after this. So endeavor to watch everything so that you can fully understand how statistical analysis is done when it involves simple linear regression. So, my name is Shedrack Akindele of the Federal University of Technology, Akure. Let's get right into the video. So, the worked example is right on the screen, and it's a table showing the diameter, which is variable x, and height, which is variable y, of 20 trees of a particular species. So the task is to compute the linear regression equation for the data. That's what we want to do. So we have two variables here. The independent variable, which is variable x, is the diameter, and it is measured in centimeters. The dependent variable is variable y, and it is measured in meters. So we want to proceed right into the analysis. So the first thing we do is we need to obtain our totals and sum of squares and sum of products. And in order to do that, we need to compute x squared. That's we square each value of the x variable, and that's what we are doing right here. You can see 45.3, that's the first value of x. The square of it is right here, 2052.09. So we do that for every single value of x. So we obtain x squared. Also, we square each value of y to obtain our y squared. And then next thing we do is we multiply x and y together. So 45.3 times 29.9 gives us 1354.5. So that way we obtain the sum of product xy. Now at the end of the table there, you will see the total row. So the first value there, 741.0, is the value of x total. That's sigma x. And then the y total is 507.8. And then you have x square total, you have y square total, and you have xy total. So you have all those totals. In addition, you will also compute the mean for each of the variables. So mean of mean of x and mean of y. So those are the things you will compute. So at the end of the day, you'll have these values: summation x squared, summation y squared, summation xy, and then n, which is your number of observations. So you count the pairs there, you have 20. And then the mean of variable x and mean of variable y. So these are the things you need to obtain to be able to enable you to do the simple linear regression analysis. If you are doing it manually using a calculator, there are some good scientific calculator that can give you these values directly. Once you input the data, you can just press necessary buttons to get these values directly without going through the long route of having to compute each of these, value by value. So it all depends. But what is important here in this calculation is to ensure that you don't make any mistake whatsoever, because all these values will be used later on in the calculation. So if there is any mistake in any of these, it will give you wrong result all through. So make sure you take time to compute this section very well to be sure that there are no mistakes whatsoever. So once you have these values, you are ready to proceed with the analysis. So the linear regression equation usually is y equals BO plus B1x. Now, in this equation, y is the dependent variable. We know that x is the independent variable, which is diameter in this case. Now, BO and B1 are the parameters of the equation. So we have two parameters there, BO and B1. So to analyze data in regression analysis, our task is essentially to compute the values of BO and B1, the parameters. Those are the values we want to estimate. And of course, there are different ways of doing the estimation, but the commonest one is usually the ordinary least square method, OLS method. So that's the one we will do. But instead of going through the derivation for us on how to derive the formula, I'll just give you the formulas directly. Formulas for computing BO, formula for computing B1. Now, in regression analysis, the first thing we will need to compute is our B1. We will need the value of B1 to estimate BO. So that's why we don't compute BO first. We will have to compute B1 first because of the value we will need later for BO. So let's see how that goes. The formula for calculating B1 is as shown on the screen. B1 is sigma x squared minus sigma x, sigma y over n, everything all over sigma x squared minus sigma x into bracket square over n. So that's the formula. Now, if you see the things we already obtained from our earlier calculation, we already have values for all the items on this formula. So the next thing we do is we just put the values appropriately where they should be. And if you look at here, summation xy, that's the value here in our computation, and that's what I have put here. So that way, just put the values correctly where they should be. Again, at this stage, you must ensure that you don't make any mistake, because any mistake you make at any stage will really give you wrong results. So when you evaluate the numerator and the denominator, you get the values there. And finally, our P1 is 0.5462. That's the value for B1. Now, from this, we now go on to calculate our BO. And the formula for BO is simply mean of y minus B1 times mean of x. So you see why B1 is important now, because we are making use of it to obtain our BO. So if we make any mistake in getting our B1, that mistake will be transferred to this stage. So that's why I emphasize that you must ensure that you don't make any mistake in the computation. So we get this. From here now, just put in the values. We already have the values for mean of x and mean of y up here. So just put the values where they should be. And that gives us 25.39 minus 0.5462, which is B1, times 37.05, which is the value for mean of x. And you evaluate that, it gives us 5.1533. That's the value for our BO. So having calculated BO now, we are good to go and express the regression equation as indicated. So our regression equation is y equals 5.1533 plus, because B1 is a positive value, so we say plus 0.5462x. So that's the regression equation we are tasked to compute. So in the next video, we will learn how to test the regression equation using some criteria. See you in the next video. Bye.